In this video, I'm going to give you some help with some questions in the piecewise function homework. So first couple of questions I think are going to be pretty straightforward, where you're just evaluating a piecewise function. Just don't forget to consider the condition, like the if statements. You know, you look at the number, like in this case, we're finding the value of the function at -4. Make sure that you know you're only going to have one answer. You're going to plug the -4 into the top rule because -4 is less than 0. Okay, so that one and the next one, those are just evaluating piecewise functions. So those should be pretty straightforward. Okay, and then graphing can be a bit more challenging. So you're going to have a couple questions where it's just kind of multiple choice. You look at the rule, you try to decide which graph represents that. Okay, so you got to think a little bit about that. Let me look at the next one. I'll do one of these. Okay, this one's more interesting. Let's look at number 3. So on this one, what you want to be thinking is first off that you've got two rules. Okay, so remember that this right here is really y. And so you have one rule being that y equals 5, one rule being that y equals -5. So you should know that y equal 5 is a horizontal line up here at 5, okay? And that y equal -5 would be a horizontal line down here at -5, okay? So we know that. We can kind of tell from the graph. What you got to decide is, where do you use the line y equal 5 and where are you supposed to use the line y equal -5? So that's where these conditions come in, okay? So when our x values are less than or equal to -1, let me change the color here. Okay, so when our x values are less than or equal to -1, okay, so let me do a blue. All right, so think about where -1 would be, okay? You would your graph would be kind of cut right here. All right, so when you're less than or equal to -1, you're supposed to use y equal 5. So when you're to the left, over here, you're supposed to use y equal 5. When you're to the right, you're supposed to use y equals -5. So that means when you're to the right of -1, you're down there at -5. When you're to the left, you're up there at 5. Okay. Now, the other thing you've got to consider is which one do you use when you're right at -1. And so when you're right at -1, you see the or equal to on that? Okay, that means you're going to use y equal 5. When you're at -1 right here, you're going to use y equal 5. So you put a bold dot there and an open circle on this one. So you go through that type of analysis, and on these problems, you also have to watch the scale because it's like 10 right here, and there's only 5 tick marks. You know, each tick mark is 2 units. That's true on the y-axis as well. So all of these have the 5 and the -5 correct. You just got to watch for things going in the correct direction, having the open and the closed circle. And so, you know, this one has the y equal 5 when you're to the right of -1. So you're going to cross that one out. These two have the correct the y equal 5 and the y equal -5 being used in the correct places. It's just the open and the closed circle. So that's where that or equal to -1 was on the y equal 5. So that's this guy right here. This one was an open circle. So D would be your answer. So you have to do a considerable amount of analysis on those to be able to get them. Okay. All right. So let's look. So here's another one. Okay, so you have a horizontal line, y equal 1, when x is bigger than 4, and you have just a regular line when x is less than or equal to 4. So you want to look for the horizontal line being when you're bigger than 4. So you kind of think it through, okay? And you can tell on that one then that you should have the horizontal line to the right, okay? So not this one and not this one. Then you've got to decide which of these it is. And so that's when you have to consider y equals the x minus 3. So just do that. Go ahead and take that. Maybe consider where it's supposed to be used when you're less than or equal to 4. So maybe plug in 4, 3, 2, 0, that kind of thing. And you get some different values. You don't have to do a whole bunch on this because it is a line. So you just have to see which of these fits, okay? Another way you could do it is the slope is 1. So that means the line should be rising. It shouldn't be falling. And so I know it's not B, has to be C, either by identifying the ordered pairs and seeing that they're located on this line right here, or by considering the slope, okay? All right. All right, the ones that I think you have the most trouble with, okay, that one's not going to be bad. Just know you're going to have a line, a slanted line, a horizontal line, and a parabola, and you got to make sure they're in the right locations. All right, the ones that I think are the hardest for people because of the notation and how you have to think about it are problems like number 6. So I want to share that one with you, kind of work it through. All right, so on this one, what you should do first is you should think, okay, first you should look at the graph and you should think, okay, this piece right here is the horizontal line, y equal 3. This piece is the horizontal line, y equals -1, okay? All right, then you want to look at where these are used. So do you see how y equal 3 is being used here? Okay, when you're going to the left, it's being used when your x values are less than, and see the closed dot on that, less than or equal to. Now here's where you might mess up if you're not careful. This point right here is the ordered pair 0, 3. You're telling me that y equals 3 when your x is less than or equal to something. So make sure you think less than or equal to 0, not 3. 3 is what kind of sticks in your head, but that's a y coordinate, okay? So that's the first part, okay? And then see how y equal -1 is used when you're to the right of 2, when your x is bigger than 2 is what you should have there. All right, so what you got to do is come over here and make sure you have the one that you can actually set up. See how the less than has to have the or equal to with it? So it's not this one you're going to use, it's this one. And so what you're going to do, I'll just write it a little bigger, is you'll say f of x is going to equal 3 if x is less than or equal to 0, and it's going to equal -1 if x is bigger than 2. All right, now there's a second part of this down below that's going to ask you for, and that's the domain and the range. All right, so if you look at the graph here, you can see the domain. The domain is basically putting these two things together. Look at the x's of all of these points right here. And you see your domain would be x's from -infinity until you get to, and make sure you're thinking x, until you get to 0 with a bracket. Then you pick up again at 2 and keep going with a parenthesis. So that would be the domain. All right. Now the range is really just two numbers. Your y values are either a -1 or a 3. That's it. So for the range, you're going to use set brackets, and you're going to put in the set brackets those two numbers. And it really doesn't matter the order because it's not an ordered pair. It's that your y values are either a -1 or a 3. Okay. All right. So let's look. Here's another one. Same concept. You got to analyze which A or B, which is going to be the thing you need to use. And it depends on where the or equal to needs to be. Does it need to be on the greater than, or does it need to be on the less than? So you have to think about that. Okay. All right. I will help you with this one a little bit. This line right here is y equal x. Okay, this line right here, the equation for it would be that y equals x, because if you look at it, you have -2, -2, -3, -3, -4, -4. So your x and your y are always the same. So that's the equation for that piece, okay? All right, now, let me see if that, and that was a closed dot on that one. All right, and the equation for this piece would be y equals 3. And then I want you to think about the or equal to and see if you can reason that out. Okay, wanted to get into some applications. This is one I like to use quite a bit. Piecewise functions are very practical. They're actually needed quite a bit when you're modeling situations in the real world. Taxes is a biggie. Okay, they're expressed as piecewise functions, not quite written in the mathematical way we normally do, but it really is a piecewise function. Each row of that table gives you a different rule that you would use to determine your tax, okay? So this is the chart that you would use to find the tax you would pay on a certain amount of taxable income, okay? And our job here is to find what the tax would be on $13,500. So what you do first, this is your taxable income, what you owe taxes on. Okay, so some deductions and exemptions have been subtracted off of your actual income, and this is all you have left to pay taxes on. Okay, you need to figure out which rule to use, and that's where these first two blocks come from. These are like your if statements if we had written it mathematically. So if your income, taxable income, is more than $8,500, but not over $34,500, then you should use this row right here, okay? And what it says is that the tax you owe is going to be, so the tax on $13,500 is going to be $850 plus 15%, and percent means divided by 100. So you got to get used to writing it as a decimal. Percent is just divided by 100. So your decimal just moves from where it is here 2 places to the left. So you do 15% of, and here you got to be careful because as you're reading it, the tax you owe is this, okay, 15% of the amount over $8,500. So you don't pay tax on $8,500 and you don't pay tax on $13,500. You don't pay 15% of that. What you got to do is take your taxable income and find out what did you earn above and beyond $8,500, and that's $5,000. Okay. All right. So that your the tax you're going to pay on a taxable income of $13,500 can be found by just typing that into your calculator. Okay. Now, if you want to write it all in one step, you could, instead of doing this over here to the side, and you could just write the $13,500 minus the $8,500 right there. Okay, I like to just kind of do it over to the side. And then you just work that out on your calculator, and that's going to be your answer. Okay, we're going to do more with taxes. We all have to pay them, and it's kind of interesting that that's really a piecewise function, just a classic example. Now, the way we would have written it would have been something like this. We would have had 3 rules. One of them would be 10% of your taxable income. One of them would be $850 plus 15% of the amount over $8,500. And so you would take your taxable income and subtract $8,500 and then multiply by 15. And then the last rule you would use is if your income was pretty high, and it would be $4,750 plus 25% of the amount of our income above and beyond $34,500. So that's how the rules would look. Then we'd have these if statements over here, okay? And one of them would be if your income was over $0, but not over $8,500. The next one says if you're over $8,500, but not over $34,500. And then the last one is if you're over $34,500, but not over $83,600. Okay. So in reality, the federal taxes, they have like, I don't know, 6 or 7 different rules depending upon where your income falls. Okay. And we talk sometimes about the 15% tax bracket or the 25% tax bracket. And what they're talking about is this piece right here. Okay. All right, so we'll do a little more with that later, but I just wanted to take a glimpse at a couple other problems in your homework. Oh yeah, the postage rates, classic piecewise function. This is actually called a step function. Okay. And so this one's asking you to find the value or the cost, how much it would cost you to mail a letter weighing 1.75 ounces. So you have to look for where 1.75 ounces would be and determine the cost. So in this case, it'd be 58 cents. All right, but that's called a step function because of all those little horizontal lines like that. And see how you have an open circle on one end and a closed circle on the other. So as you increase your weight, you're going to jump up to the next cost, and then you're going to jump up to the next higher cost eventually. Okay, very common. All right, and then here we have another really common application. This one doesn't really go on and ask the question I really wanted to ask, but okay. So on this one, you've got a situation where the phone plan is set up where you pay, this is the cost, okay, and this is the number of minutes. What's really going on here is you're paying a flat fee of $20 for a while, up to, let's see, this one says up to 300 free minutes. But once you go to 301, 302, you know, once you go past 300 minutes, then you're going to be adding 20 cents for every additional minute. So your graph looks something like this, as two different pieces. This piece is the y equal 20. So that's this rule. And then this piece is where the rule y equals 20 plus 20 cents for all the minutes beyond 300. So if you subtract 300 from your number of minutes, that will tell you how many extra minutes you had, and you pay 20 cents for those. And so it causes you to have a line with a positive slope. All right, really all this problem, though, is asking you to do is to simplify the second rule. So all you really do there is distribute, and you'd have it. But, you know, you could think about, well, what would be the cost if I used 350 minutes in a month? And you'd have to be thinking about the fact that you wouldn't use the top rule, you'd use the bottom rule, and you'd plug in 350 in here. And so your cost would have been 20 plus 20 cents times those extra 50 minutes. Okay. But if your cost was, or your number of minutes was like 100, then the cost would just be $20 because you get 300 free minutes. All right, so let me stop this video. Just wanted to do some extra help on the Piecewise homework. People were expressing some concern about that, and I thought it might help if I just did a few, okay? All right, so hope that helps. Let me go ahead and stop this and get it posted.